Okay. Guys, laptop's done for now. You can do it later. Just for now. You too, Jade. Phones away, laptops away for now.
What are we starting on, sir?
Hey. So I forgot how to do it. Oh, I'm on a big
Chris. Okay. So perimeter of a triangle, that's pretty easy, right?
Yeah.
So it's just 3 plus, this is revision. 11 centimeters. What does peri mean again? Around outside.
Is that 3 or plus?
Sorry?
Is that a times or a plus?
What, sorry?
Is that a times or a plus?
It's a plus, sorry. There you go. Jade, come on, just put it away. No. I said. No. Okay, okay, leave it there. Jade, what's this side here?
That's 20.
Yeah? In 1 centimeters. What's the side here as well?
It's 20.
20? Okay, good. So what's my perimeter?
Yeah.
Yeah, okay, so it's 3 times 20.
So that equals 15 centimeters.
So do you add the line on the inside as well?
Which one?
That line on the
No, you
inside?
don't. You don't.
You don't? So how much you get, yeah?
Okay, so plus 10 and then plus 22. What's that equal to? Yes, guys, write it down. Write this down.
72.
Yeah, everyone write this down.
Is that there the whole time?
So how the hell is that 22 here?
22. I just rounded off. Okay. What's the answer?
72, isn't it?
Is it 72? Okay.
60, 82, 92. 92, sir. 92.
92. Alex, what's the answer?
92.
And then you say 92?
It's not me.
Yeah, 92.
So part A is finding the greatest potential error. Error of these two perimeters. Okay. So guys, do you remember finding the greatest potential error?
Yes.
Yeah.
Yeah. Was I here?
Yes.
He wasn't here. He wasn't here.
I swear I wasn't.
But I forwarded you those. Did you look at the email? I forwarded you the slides. Did you look at them?
Oh, yeah. No, I didn't.
Okay.
Yeah,
So you know, right, Alex?
Yeah,
Okay.
yeah, you said
What's the
that
limit of reading?
1
1 centimeter. Thanks, Johnny.
Johnny.
Johnny, sorry. Okay. Min. So how do we find the greatest potential error of one of our readings? So that's the limit of reading, but I want the greatest potential error.
You half it.
Half it. That's hands up, guys. Hands up. Half it. Thank you. So
Good sir, yeah, I remember.
1 centimeter divided by 2, so it equals to 0.5 centimeters, right? So that's the limit of reading for one of the measurements. So is that the answer, guys?
Yeah, it's 11.5.
11.5? No, I just want to find the greatest potential error of the shape.
Yeah, that's it.
Okay. How many readings are we doing here? 3. So we're measuring it 3 times, right? So if we measure the first time, there's a greatest potential error of 0.5. Measuring it the second time, another greatest potential error of 0.5. And then measuring it for a third time, that's another greatest potential error of 0.5. So what's the total?
1.5.
So there's the greatest potential error for
That's
the...
because there's 3 sides, yes sir?
Yeah, that's good.
I have it for that one. There's about 5 sides, but you only need 1.
Of A
Or B.
is 0.5 times 3 equals to 1.5
So what's the
centimeters.
point of greatest potential error?
Sorry?
What's the point of greatest potential error?
It's just that when you do readings and measurement, there's an accuracy, alright? Remember how I said it just measures to the closest degree? So it's hard to measure something to the exact degree. So you give yourself a half leeway above, half leeway below. Okay? So that's why we do it. Just a leeway in accuracy. Okay. Sorry, Omar? So that's asking for the greatest potential error for the perimeter. So you do it that way. So if it's asking just for a length, you do just the length.
Does that mean for B, 6 times 0.5 times 6?
So it doesn't give you an exact answer, it just gives you...
So you do 0.5
Okay,
times 5.
guys. John, what shape is that? What shape is this?
Triangle.
What shape is that? We just did it. A square. Not quite. Not quite. It's a quadrilateral. Trapezium. Did you say that? Yeah, it's trapezium. Good job. Trapezium. Guys, hands up. Okay. So for our triangle, the greatest potential area for the perimeter was 3 times 0.5. For this quadrilateral, what do we have to do it by? 4. So hold on to the thought, John. 4. How many measurements have we taken? So look at the black. That's 3 measurements, right?
Yeah.
So that's what you were given. So you have to assume that this is 20 and that's 20.
Yeah.
So how many measurements did we take total?
5.
5. So if we've taken 5 measurements, right? Then the greatest potential error wouldn't. I know it's a quadrilateral.
2.5.
Yeah, that's good. I know it's a quadrilateral, right? But we have to take 5 measurements. So each time we take a measurement.
So can you number the 5, please?
Yeah. So 1, 2, 3, 4, 5.
Isn't it 6?
No, 1, 2, 3, 4, 5.
Oh,
So the
that
black.
colour's line is
So
so
John, the
black.
black was given. The black was given, and then the purple I just added it in to fill it out.
Yeah.
So there's five measurements, right?
Done.
Cool.
I like the way you think.
Also,
So,
the dotted line doesn't
It will
count.
be 0.5 times 5 equals to 2.5 centimeters for the greatest potential error.
Wait, so what's the 2.4?
2.5, because each length, right? It's a 0.5 greatest potential error, and we're taking 5 measurements. So that's a question that might throw you off in examinations, right? Even though it's a quadrilateral.
You need to show working out for that?
This one?
No.
What did you say, sir? Even though it's a quadrilateral.
Even though it's a quadrilateral.
In the exam, do you really need to do 1 centimeter over 2?
I think that would be probably 2 marks. So if you have like something like this, and then that's fine enough. So even though it's a quadrilateral and it has 4 sides, you look at how many measurements we're taking.
Yeah.
And you can see 5
And you don't
measurements right
count
there.
the ones in the middle.
No, that's
Area.
perimeter.
That's area.
That's just like a dotted line, just to show you that it's a triangle there. Okay.
Metro boom. Toilet paper roll for yourself.
I'll tell you later.
Z, did you get a roll for yourself? What do you mean? Because you have 2 in your bag already. You want one?
Fold up.
You want one?
So that was just revision for perimeter and greatest potential error. So it's good that no one's forgotten about it. Okay. So remember last lesson I was trying to explain why we got area formulas for each shape. Everyone remembers it, right?
Yeah.
So do you know why we can get an area of a circle? How it came to be?
The earth.
Pi. So we know. So guys, what was our circumference again?
360.
Yeah, and what was the formula for the circumference?
I forgot.
2 pi up.
Is there a formula sheet in the exam, sir?
Yeah, there is.
Thank God. I'm not going to remember that.
2 pi r. Okay. So to find the area of this circle, what we can do is
2 times pi times the radius. I think.
almost. I'll show you.
No, the circumference.
But isn't 2 pi up there? Remember?
I'll show you. So imagine there's like millions of circles because it goes on forever, right? Forever.
Yes, everything can be accessed. I don't know why you guys are talking like
Okay. Just imagine there's millions of circles, right? And then I'm gonna cut a line across here. I'm gonna cut it. So that's the radius, right?
Yeah.
So the biggest circle on the outside is the circumference, right? On the outside, that's the biggest one. So that will be here. So that will be equal to 2 pi r. So the next biggest circle will be there. The next biggest one will be there. The next biggest one will be there, right? It keeps on going. Okay.
Wait, why are you drawing lines now?
Sir, I don't know why you're drawing lines.
Imagine a circle, and there's millions of little circles, right? Making up that circle. So little circle and bigger circle.
Breaker.
Yeah, jawbreaker. A jawbreaker, but that's a sphere. But, all right, it keeps on going. Okay, so the biggest circle is going to be 2 pi r because that's the circumference, right? So the next biggest circle will keep on going. Keep on going until you get. So what shape is this?
That's triangle.
Cool. So that would the circumference is equal to 2 pi r. What do you reckon that's equal to?
2 pi up.
The
Oh, the
radius.
radius.
90.
Okay? What's the area of a triangle, guys?
No one.
Area of a triangle.
So you're making it too confusing.
Area of a triangle.
I never
is
said this
100.
No, we'll get into it.
That's all.
So half times base times height. Okay? So I'm going to substitute it in. Our base is r, and what's our height? 2 pi r.
Wait, what's going on, man?
I'm trying to explain to you why pi r squared is the area of a circle.
Also, I don't even know that.
You know what?
Don't
So
understand.
Don't worry about
So that's like saying, well, what's my name here?
it. So you cancel it out, right? And that's equal to pi r squared.
Don't worry about that.
Okay.
Sir, you're teaching us. Oh.
What about those things?
You guys have to have the understanding of mathematics as well.
Yeah, what's this going to
As long as we can answer, there's not enough time for the exam. As long as we can answer it, so that's all that matters.
Thanks, guys.
So we're never going to use this in life anyway.
You might have a kid,
Huh?
and you might want to know.
Man, brother, I have kids all over the world, bro.
That's why you should on YouTube. What's my black? YouTube 2017.
Remember the last thing page tips change his sexuality. That's how things change so fast. Hey Louis, you just could be cutie, that's gay. You have to be quiet.
I know what you're doing. Yeah. Easy stuff.
Put it on quick shit. Come do it.
So we're looking for the inside now.
Areas.
How do we do that? Done, you sir. Can you just draw a line?
Now next my egg to drop. I'm going to drop.
I think you're a good man, sir.
That's how it works though, it's like.
Oh, that's a composite shape.
Much about it.
Oh, it's right there.
Oh, so break it up. Yes, so don't you just draw lines and make it precise?
So that's two
break it up.
rectangles. Two rectangles right there.
We could.
That's four.
So there's two ways of doing it. I'll show you the first way. Okay.
Oh, okay, yeah.
So the first way we can do it is subtraction.
Subtraction.
So do you want us to draw a shape?
Yeah, draw the shape. Guys, everything on the board, you have to go into your books as well.
Alright, so let us draw so.
Okay. So, what's our length across here? Arthur,
8. Oh, yeah.
guys, no calling out. No calling out. Satirius, what's our length across here? So this is equal to 4 centimeters, right? And they're equal to 2 centimeters. What's the length across there? 8 centimeters, thank you.
That's tall.
Okay.
How's it 2, 2, 4, and 2, 2. It's tall. How's it answer?
2, 4, and 2
That's all.
is 8, okay? And this is also 8.
Good man, sir.
Okay.
Show it on YouTube.
I bet you can.
So I want to promote your channel somehow. What do you reckon I should do?
Put a subscriber button, sir.
So what I'm going to do first,
So you're going to be surprised how many
You get those subscribers in jet from school.
what I'm going to do first is find out the area of the big square. Yeah, what is it? Yeah.
Wait,
It's a
so,
square.
so why are we moving on to a
So you
square
times
now?
about 4.
Okay.
Actually,
So what are these?
8 times 8 times.
So what are these? What are these?
8 squares.
That's 2 centimeters.
Yeah. So they're 4 little squares. So if I got that big square and we're using subtraction, we're gonna minus 4 of those little squares.
So you always have to put the square
Doing
there.
that is extracting the little squares.
So the area for that is 64 centimeters squared.
But wait,
So
that's by subtraction, right?
Formula is just S squared.
Okay, so that's equal to 64 centimeters minus 2 times 2. 4.
It just made 2 times 2.
4. Because there's 4 of them. There's 4 of them. Okay. So your names. No, Johnny, everybody. Kelvin.
So where did you say that's the side of the equation?
Do what?
The side of the equation.
So Kelvin, what's our answer? So we get the big square, which is 64 centimeters squared, minus 4 little squares. Okay. And our little square is here.
Yeah.
What's the area for our little square?
Where's I'm a bit confused.
What's the area for our little square? It's right. Kelvin, what's the area for this square here? The area for this square. Yeah, 4. It's 4 because it's 2 times 2, right? It's 4.
So does that say minus 4 brackets 2 times 2?
Why would you do that?
Because it's yours.
It's his.
So
That hurt my head.
does that say minus 4?
Minus 4.
Yeah.
And what's the answer, guys?
The answer to that one, sir, is 64 minus 4 bracket 2 times 2, which equals 48. Oh, did you work it out already, sir?
No, that was accidentally. See if it doesn't have like meters or centimeters or something.
Does anyone have it down already? Has everyone written it down?
I'm still writing the right side.
Okay, that's fine. So that's by subtraction. Okay.
It's how do you find K? What do you mean? It's right there.
So William, we had subtraction before. Guess what this method's going to be? Addition. Thanks, guys. Okay. So Tony, which one's Tony? Guys, come on. So Tony. Tony. So which areas am I going to add? So I just drew. So the shape looks like this, right? So we can do it either way. We can draw a line here, or we can draw a line here. It doesn't matter. Okay. I'm going to go across here. So that's area 1, and that's area 2. Okay. It's alright. Juan. So what's the formula for what's the equation for area 1? Good.
Is that 10 squared? Is it 10 squared, sir? 20 times 10.
Yeah. Let's have a look. Have a look for you. Okay. And Taya. Where's Taya?
Teo.
Taya. In the back. All right. And William. Is he here today? He's away. That's all right. Kevin, what's the area for the second one? Yeah, what is it?
18 to
Yeah, because we got minus 10, right? Yeah, so 18 times
How do
10.
you do area, sir? How come you're adding? Oh no.
Okay, so the total area.
Sir, you didn't explain to me how to do it.
I will, Jade. So, just to clarify, our second method is we're going to find opposite shapes. Let me finish. Because you're going to ask a question, I'm going to say it, right? So I want you to listen first. So the first thing we do, we need to divide it up into different shapes. That's easy to manage. Okay? So that's what the shape looks like first, right? That's what the shape looks like at first. I just put in a line here. Separate it. Now that's area 1 and that's area 2 down there. Okay? So this side here, alright, is equal to 28. Alright? 28 minus 10. So that's equal to 18 meters. That's right there. So that's equal to 20 times 10, 200. And then 10 times 18, which is 180. And if I add them together, I get total area, which is 280 meters squared. 10 on that.
So why we minus it?
Because to get this length here, that length there, is equal to 28 minus 10.
Wouldn't we just half 28, which gives us 40?
It's not half. It's not half.
Oh, that's not half.
Yeah, it's not half.
Oh, okay.
Yeah, you gotta go by what that is. Yeah, what that is. So it's not half.
Oh, okay, yeah, yeah.
Does that make sense?
What? That's what I do.
So the other thing is going to
I do.
Actually, give it to us. That's what you got to
last time.
Yeah, we organized. Yeah.
Also, I do have
Guys, go to the link. Go to the link. I gave you the drive. Okay, I'm going to tell you how I'm putting your homework to do. So go to the link, right? Go to the drive. And then you're going to go to inside text. So there's a homework to-do list. It's a Google Doc. So there's a to-do list. If you can do that, right? If we can do it, guys, this is not in your Google Classroom. This is in that slip I gave to you. Does everyone have this slip? Okay? Yeah, there's instructions on it. So bookmark the first link. Make sure you have access to my... Make sure you have access to this drive. I will be communicating it through you guys.
do that well, does that mean we'll do good in the exam?
Of course. What?